Hello everyone, welcome back to the channel. So today we are doing Leetcode 1751, maximum number of events that we can attend, version 2. So we did version number 1 yesterday, which was a medium rated problem, and this is marked as hard. But when we actually think about it, it's not actually that hard. It says that you're given a 2D array, something like this, okay? You're given a 2D array where you have the starting position of an event, so when it starts, when it ends, and if you attend this particular event, this is the value that you get. So you get a value of 1. All right, you have something like this. The thing is that there is a limit on how many events that you can attend overall, and what you have to do is you have to maximize your gain. All right, so you have to maximize the value that you get out of the events. So right, before jumping into the test cases, if we read this particular paragraph, it says if you attend an event, the end day is also inclusive, right? So if I'm attending this first event, then that means it starts at 1 and it ends at 1 as well. So the next event that I attend, it needs to start from 2. So the starting time of the next event, this particular thing, it should be greater than the ending time of the previous event that you attended, right? That is something which is very important. Now if you look at the test cases, I have one event which starts at 1, ends at 2, starts at 3, ends at 4, and then I have the third event which starts at 2, ends at 3, with a value of 1. The limit that is given to me is 2. So based on the value, I'm going to prioritize the first and the second event. So overall the answer comes out to be 7. Similarly, in the third example, I have k as 2. I'm going to ignore the first two events. I'm going to go with the third one because that is what maximizes my overall answer. Now in this particular test case, what you're going to see is that you have no overlap, right? You have exactly no overlap, but then you're going to prefer the second, third, and fourth event because the limit is 3. If the limit would have been 4, you sort of would have attended all the events that you have, right? Okay, perfect. Now this particular question seems very similar to something that we study in university, and that is known as the knapsack problem. And this is something which is pretty standard, like one of the most standard problems out there in comparative programming is the knapsack problem, right? That's where you start to build your thought process. So if I have two examples in front of you, all right, let's first look at a simpler example. Let's say that you have a bag, okay? The capacity of that bag is 10 kg. So you're going to put some weight inside of it, some number of items inside of it, and those items, each of those items has have some weight. So item number 0, item number 1, item number 2, they have some weight, and then they have some value associated with them. Now what you need to do is, since this bag has a capacity, you can obviously you need to prepare very well in order to decide, in order to distinguish between different items. What should I take, what should I not take, right? So you need to make a decision between what you need to take and what you need to skip. So in this scenario, what I'll do is I will go with these two items, 4 and 6. 4 plus 6, the weight is 10, which is equal to the capacity of my bag, and the value that I get is 2 plus 5, which is equals to 7. Similarly, this is another example. Let's say you have a bag of 22 kgs, you have 5 items, and now you need to decide which item to take and which to not take. So in this sort of a scenario, what we usually do is we come up with a recursive approach and we try all the possible paths that we have. Let's see how that looks. All right, so I have copy pasted this same exact test case over here. Let's see how we are going to decide which items to take and which items to not take. So what we do is, we are currently standing at 0. We decide about whether we want to take the item at the 0th index or not, right? So let's say I'm starting initially, I have some sort of capacity which is 10 kg over here. So I'm starting with a capacity of 10. I am standing at index 0, and the current value that I have gained is also 0. So we will talk about how we are going to work out with the value. So I have, this is the capacity that I have left, and this is the index that I am at. Now one thing can be that I take the item at the current index, the other thing that we can be that I do not. So if I take the item, how that's going to look like is the capacity is going to become less, obviously, because there is some sort of weight associated with the item. So the remaining capacity will be 6, and the value which that I will have gained is going to be +2. So when I return from this particular call, I am going to be what I'll do is I will return +2 from here when I go upwards, right? I'll return +2 from here because I have taken this weight. So what I'll do is, let me change this. What I will do is, so this recursive call, basically 2 plus this particular recursive call, and then if we do not take the item, then we just increment the index and we do nothing with the capacity. Then I have two choices, whether to take the item which is at index 2 or not. Now what you're going to observe is the weight of this item is 6, but then the capacity that I have left is 6. So the only choice that I am left with is I need to skip. It is sort of imperative on me to skip. There is no way that I can take this particular item. So what's going to happen is this is going to remain as is. So I have 6 capacity left and 2 uh, second index I am on. Similarly, over here I have two choices, whether to take this or not. If I take this, what happens? If I take it, then 2 capacity is left. I am at index 2, and since I'm taking it, there's going to be 6. So I will do 6 plus this particular recursive call, right? Perfect. And then if I ignore it, I have 10 comma 2 over here. Similarly, now I have 3 states. So from 6 comma 2, I am at index 2. Can I take this particular item? Yes, I can. So what I will do is I will have left 0 capacity, and the value which was associated with it is 5. So 5 plus this particular recursive call. If I don't, then I don't. So I will be left with the same capacity, and index will be 3. Similarly, over here, when I make the recursive call, I have 2 capacity left. The only thing that I can do is ignore. So it's going to be 2 comma 3. And similarly, over here, I have two choices. I can take the last element. If I do, then I will have 4 capacity left. I will have 4 capacity left. I will be at index 3. And since I'm taking the particular thing, it's going to be +5 over here, right? And then if I ignore it, it's just going to be 10 comma 3, right? Now, since we are out of bound, there is no index 3. What we are going to do is this particular recursive call, when the index has reached 3, this is going to return 0. So what I can do is replace this with 0. Since we are out of bound, this is 0. Okay, so this is 0 and this is 0 as well. Perfect. So over here I have 5, over here I have 5, and the rest of them are 0. Now what we are trying to do is we are trying to maximize the value that we can gain, right? This is basically the value which we are gaining. So from the take option I get 5, from the not take option I get 0. What's going to reach at this point? Whatever the maximum is between these two. Similarly, whatever the maximum is, so over here I just have 0, so 0 is going to reach over here, and over here I have 5, so 5 is going to reach at this place. Now again, same thing, this is just one state, so 5 is going to reach over here, 6 comma 1 is going to be replaced with 5. From over here, 2 plus 5 is 7, so 7 goes over there. Similarly, I have 2 comma 2 becomes 0, so I have 6 from this, I have 5 from this. Whatever the maximum is, that is going to be that is going to go up, and from both of these scenarios I have 6 as the maximum. Now 7 reaches from this, 6 reaches from this. Who is greater between 7 and 6? So the overall answer that I return is 7, and 7 is like when we actually visually saw the problem, we took these two items, right? So what I'm doing over here is nothing but a simple DFS, a depth first search approach, right? Now, why have I made all of this recursive tree in front of you? Because if you look at the problem, what you will observe is that these events, when you're talking about these events, you also need to make a decision. Which event should I take and which event should I ignore? Isn't it? So this very, very closely relates to the recursive tree that I have made over here. and let's see how we can take the same approach and apply it over here. So what I have done is I have made a global nums array. I have initialized it with events so that I don't have to pass it everywhere. It's global. I have sorted the nums based on their starting points, because obviously um, since these are events and they have some sort of starting time, some sort of ending time, I can just sort them and then do the processing on them. Then what I have done is I have created a solve function wherein this 0 is the current index that I am at. The k is sort of basically my capacity, the number of events that I can take at maximum. And the end is basically when a particular event ends, right? And why am I keeping track of this? Because what we saw in the problem statement is when, so for example 1 comma 2 comma 4, now if I'm taking event number 1, it ends at 2, so the next event that I can take must and should start from 3 or greater than 3. All right, so it obviously means that we need to keep track of what the end is. Perfect. So I'm standing at event I need to take, I need to decide whether to take the event or not. So what I will do is I will create a take variable. I will assign it initially 0. And then I'm going to see, okay, if end is either equals to -1, or or end should be greater than, strictly greater than whatever is nums of I of, what would it be? So end is basically the ending time. Ending, if I'm taking this particular event, let's say if I'm taking this particular event, its starting time should be greater than the previous end. So it would be nums of I of uh 1 over here. Yeah, right, because the ending time of the previous event was 2, and I am saying that the ending time should be less actually. The end of the previous event should be less than the starting of the current event. So nums of I of 0. Yeah, perfect. The ending of the previous event, or let me actually make this end of previous event, right? The ending of the previous event should be less than the starting of the current event, which is nums of I of 0. Then what I will do is I will say, okay, take is equals to um or maybe something like take plus equals what, the value that I gain, which is nums of I of 2, that is something that I gain, plus hit the recursive call again. So go to I plus 1. Okay, go to I plus 1 and do k minus equal 1 because you have taken one event. And now you see the ending is going to update. Let's say that I am taking this particular event, right? So previously the ending was -1, the end time was -1, but now it's going to become what? It's going to become 2. Perfect. So it's going to be nums of I of 1 over here. So for the next event, this is going to be the end previous. Perfect. Zabardast. Now I need to take the skip, and skip is just going to be simply solve of I plus 1, k remains as is, and end of previous event remains as is as well. As simple as that. And what I need to do is just return whatever the max is from take and escape. Now, only the base case is left. So what the base case for this particular DFS is going to be is if the index is greater than equals to nums dot size, obviously, or if k equals 0, if we do not have any further capacity left, then what we do is we just simply return 0, right? Perfect. So let's see if it passes all the test cases. I have a compile error. Why is that so? Because and equal -1 and previous, right? And previous. Okay, let's see if it passes the example test cases. Yeah, ultimately obviously, let me actually remove this particular test case. It's a pretty large one. It's obviously going to give us time limit exceeded, but then I just want to see if this logic works on a smaller test cases, and it clearly does, right? Now, something to think about is, obviously, since it gives us time limit exceeded error, I would have to memoize this. What I can do is right now three of my parameters are changing. So what I can do is I can simply take a map of something like this. So pair of int comma pair of int comma int, right? Something like this. So against 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 something like I will have, uh, I comma k comma and previous. This is going to be my key, and against that I'm going to have an integer value. But rather than doing this approach, what I can do is, if you think about it, do we really need to keep track of what the end previous is? Do we really need to do that? Let's see. I don't think so, because what we can do is, inside of our code we can just iteratively, we can do a linear search simply on, given that this is my current event, I can do a very easy linear search on what should be the next event, isn't it? I can iteratively see that. So what I'm going to do is, rather than keeping track of what the ending is, okay, I will do something like this. So I don't need to pass end previous over here. What I will do is, in order to find out what the next index is, I will do something like this. I will have int or for int j equals I, right? Starting from, or actually I plus 1, because I'm searching for the next index. J is less than nums dot size and j plus plus. Now, what I am looking for is a starting point. I'm looking for a next starting point. Is a starting point such that such that it such that the the starting of it the starting of it should be greater than the ending of previous event. Right? Previous means actually my current event. So ending of current event. I'm looking for a starting point of next event such that the I'm sorry, such that the starting of it is greater than the ending of my current event. So what I can do is, uh, I have okay, if if nums of j starting point of next event, nums of j of 0 starting point of next event, if it's greater than the ending of the current event, so nums of I comma 1, then I'm going to say, okay, next index is equals to j. Just save that and break out of the for loop. Perfect. Sounds good. And then, rather than, what we were doing is, initially we were doing something like this. So we were doing take plus equal whatever value that we get, nums of I at 2, plus we hit a recursive call on, we were doing I plus 1, but rather than doing I plus 1, we can do next index comma comma k minus 1, right? So let's see if this passes all the test cases as well. What benefit this is giving to us is that we won't have to, why is this wrong, by the way? Because I forgot one over here, but I don't really need this. So yeah, what why we are doing this is because if I can remove one parameter from here, it's going to help me when I memoize the solution overall. I need to remove this as well. Let's see if it passes the example test cases, and if it does, then we'll try the memoization. It does very clearly, so we didn't really need, we just needed two particular indexes. What I will do is, now I will take a vector of vector int as a global vector of vector int dp. What I will do is, I will go over here, and before calling the function, I will just do dp.resize. And how do we actually do this? Let me just have a look. Or maybe let's just do it this way. I just say that dp is equals to vector of vector int k plus, I'll change these. All right. And over here, I've defined it, and over here I will assign it a value. So the first parameter that I have is I and then k, right? So at maximum, I can go, the I index can go up to 10 to the power 6. Events dot length can be 10 to the power 6, and k can be equals to 1. So, or rather than, since we are doing it in the main function, what I can do is just events dot size over here, right? And k plus 1 over here, right? Perfect. So this is my dp vector, and I need to initialize it with -1, right? So how that's going to work is like this. Rather than doing k plus 1 over here, I need to say vector of uh, vector of int and then the constructor. So k plus 1 comma -1. If I just sort of compile the code, I hope everything checks out. Yeah, perfect. And then I just need to see if dp of I comma k, if it exists. If it's not equals to -1, if it's not equals to -1, just return whatever dp of I comma k is, as simple as that. And then at each and every step, since you are calculating it, also cache it. So save it, please. Before returning the value, save it in the cache. So yeah, this this is how memoization works. So if I sort of submit this, if I submit this particular code, let's see if it passes all the test cases. It won't, obviously. It's going to give us a time limit exceeded error, but I just want to show you how many test cases out of the overall ones it passes. And it literally passes 69 test cases. It's just one test case that is failing. Now what we are doing is, okay, we have two parameters and we are memoizing over them, we are doing everything right. But then the thing is, since the events array is sorted, why are you doing a linear search, right? If the array is sorted, why are we not going for binary search? So let's have a look at how that approach works. Okay, so like we said, instead of doing linear search, let's find the next index in a binary search sort of a way. So I'll just remove this, and what we want to do is we want to binary search to find next index. So what I will do is I'll create a function which is let's say, or let's call that over here actually, find next index. And what I need to pass to the find next index, what does find next index gives me? Find next index returns me the starting point, basically the starting point of next event. Perfect. And the starting point of next event is based upon the ending of current event. So ending of current event is what? Nums of I of 1. So I need to pass nums of I of 1, and find next index is actually nothing, it's just pure standard binary search. So I have a left pointer, I have a right pointer, I calculate the mid. I events is by default it's global. I see if events of mid comma 0 is less than equal to target. Let's actually, what we'll do is, rather than saying target, let's say that ending time. Ending time of whom? Ending time of the, of which event? The current event or the previous event? Ending time of the current event. Why? Because we are trying to find out the starting point of the next one. So this ending time that we are referring to over here is actually the ending time of the current event, and ultimately it's going to return you the index of whatever the next event is. So what we have done is literally nothing, but just we have replaced a linear search to a binary search, right? Now if we submit this code, let's see if it passes all the test cases that we have, right? It should actually. I am very hopeful. Let's see. And it does, right? So this was actually a very good question in terms of the concepts that it relates to. So it teaches you how recursion works. And then since this is marked hard, why it's marked hard in my opinion is because it involves two different concepts, right? So it involves the concept of the knapsack problem, so where you have to recursively you have to make a decision based on whether to take the current event or not. And then it also involves binary search inside of it, because if it wasn't binary search, it was a pretty standard knapsack problem sort of a thing, right? But then the fact that it involves binary search as well is I think what makes it just what justifies it as a hard problem. So I hope you understand each and every step that we did, the logic behind each and every step that we did, and I will see you in the next one. Take care.